Some days after officially kicking off science operations, NASA's James Webb Space Telescope sent astronomers down a realm of early galaxies. The findings have surprised everyone and challenged what astronomers thought they knew already. If you're interested in knowing more about what scientists recently discovered through the telescope, stick around to the end of the video. The $10 billion observatory, the biggest and most powerful telescope ever launched into space, is in a solar orbit a million miles away from Earth. Full science operations kicked off over the summer, and NASA has since released a series of amazing snapshots of the universe. The Webb telescope has literally opened up a new frontier and brought humanity much closer to understanding how everything came to be, and this is just the beginning too. There's a long and exciting road up ahead. This telescope was a collaboration between NASA and the European and Canadian space agencies. It also took 30 years to construct, and it employs 18 hexagonal mirrors. The data and images from the telescope offer small glimpses of history that could only be imagined up to now. The initial images and data from the telescope confirmed how quickly our understanding of galaxies is shifting. The telescope has blown astronomers away with every new development. This telescope also discovered carbon dioxide on a distant planet and also tracked a live asteroid, probably the best $10 billion ever spent. Scientists had held onto the hope that the world's most advanced space telescope would shed light on the unknown, and that's exactly what it did. The Big Bang, a theory taken as true by many scientists, states that our universe began as a dense, heated bundle of matter so compact that it would have looked like a single point. That bundle then grew rapidly, out of nowhere, giving rise to a primordial soup of tiny particles that then went on to become the universe we see today. 2 research papers about this recent development have been published in the astrophysical journal Letters. These initial findings are from a broader Webb research initiative which also involves 2 early release science programs: the Cosmic Evolution Early Release Science Survey and the Grism Lens Amplified Survey from Space. Although some researchers previously reported having found galaxies even closer to the creation of the universe, which was 13.8 billion years ago, those findings are yet to be verified, scientists stated at a NASA news conference. It's also possible that some of those supposed galaxies could be later ones that were just imitating earlier ones they noted. After a mere 4 days of analysis, researchers discovered 2 surprisingly bright galaxies in the images shown by the James Webb Telescope. These galaxies lie approximately 450 and 350 million years after the Big Bang, with a redshift of approximately 10.5 and 12.5, but we're still waiting for future spectroscopic measurements with the telescope to help confirm. Tommaso True of the University of California at Los Angeles had this to say about the development: "Everything we see is new. Webb is showing us that there's a very rich universe beyond what we imagined." He continued, adding, "Once again, the universe has surprised us. These early galaxies are very unusual in many ways." Scientists were amazed to find the most distant starlight that anyone had ever seen days after Webb revealed its first data, is what one scientist said about the more distant glass galaxy. The last record holder is galaxy GN's 11, which existed 400 million years after the Big Bang and was discovered in 2016 by the Hubble and Keck Observatory in deep sky programs. Considering all the predictions, they had to search a much larger volume of space to uncover such galaxies, and these new observations are making scientists' heads explode. It's the mark of a whole new era in astronomy. It's not unlike an archaeological dig, and this would be the equivalent of uncovering a whole new city. Even though the distances of these early sources still need to be confirmed with spectroscopy, their extreme brightnesses are really confusing and challenge our preconceived ideas about the formation of galaxies. Astronomers speak of these far-off galaxies as appearing extremely red. That's because they are so far away and move so quickly that the wavelengths of light are stretched by the expanding universe. Their brightness and tidiness indicate that early galaxies had already developed organized structures out of many stars, rather than being faint and muddled as earlier studies with the Hubble Space Telescope had shown. The Webb observations are pushing astronomers toward a consensus that an alarming number of galaxies in the early universe were much brighter than predicted. This will make it easier for Webb to discover even more early galaxies in subsequent deep sky surveys, according to researchers. Garth Illingworth, a member of the Naidu/USH team, said that they finally nailed something that's extremely fascinating, and these galaxies probably started coming together 100 million years after the Big Bang, also showing a possibility that the Dark Ages ended sooner than we thought. The primal universe would have been just 1/100th its present age. It's a speck of time in the 13.8 billion-year-old cosmos. Illingworth also called it a very dynamic and exciting time for space discoveries and confirmed that there were plenty of preliminary announcements of even earlier galaxies, and that their team is still trying to sift through those together and find out which ones of those are likely to be real. True said the evidence they come up with so far is as solid as it could be for the galaxy that was thought to have formed 350 million years after the Big Bang. If the findings are confirmed as real and more early galaxies do lie out there, Radu and his team wrote that Webb will turn out to be highly successful in pushing the cosmic frontier all the way to the edge of the Big Bang. Erica Nelson, another member of the team, noted that their team was awed by being able to measure the shapes of these first galaxies. Their calm, orderly disks throw into question our understanding of how the first galaxies came to exist in the early universe. And this amazing, game-changing discovery of compact disks at such early times was only possible as a result of Webb's much sharper images in infrared light as compared to the Hubble telescope. These galaxies are quite unlike the Milky Way and other big galaxies we see around us today. One thing that should be emphasized is that the two bright galaxies found by these teams are full of light. One theory is that they could have been very big with lots of low-mass stars like the later galaxies. If not that, they could be less massive and consist of much fewer extraordinarily bright stars, also known as population IU stars. Long theorized, they would be the first stars ever born, burning at scorching temperatures and consisting only of primordial hydrogen and helium, before stars could later cook up heavier elements in their nuclear fusion furnaces. No such extremely hot primordial stars have been spotted in the local universe. Adriana Fontana, a scientist who authored one of the two research papers, claimed that the farthest source is very compact, and its colors seem to hint that its stellar population is lacking heavy elements and might even contain some population IU stars. The only way to know for sure is through the Webb telescope. Present Webb distance estimates that these two galaxies are the result of having their infrared colors measured. Eventually, follow-up spectroscopy measurements displaying how light has been stretched in the expanding universe will give independent verification of these cosmic yardstick measurements. When and how the existence of the galaxies came about is a question that has always plagued scientists, and the James Webb Telescope has by far outclassed its predecessor, the Hubble. In fact, these galaxies lay right under the limits of what the Hubble telescope was capable of. Looking back to the very early universe allows humans to ask profound questions about our place in the cosmos. The whole thing is a part of our origin story as a species, and we're excited to see what the telescope finds next. Meanwhile, scientists are looking more broadly at the information the telescope is revealing about galaxy formation. A team working with Webb analyzed 26 galaxies observed by the telescope, the preliminary redshifts from 9 to 16. That work, too, supports the findings and backs up the claim that there are many more bright galaxies at these distances than the theory had predicted. Whatever information the James Webb Telescope has provided so far has turned out to be an exciting teaser of the potential secrets of the universe. With these findings, we now know that galaxies began forming faster and earlier than previously thought, and they have way more light than expected, meaning the dark age came to an end earlier too. It's always incredible to find that there's an even richer universe out there than we imagined.